So we'll be seeing more on enthalpy, and then we'll be seeing standard states. So suppose we have a reaction that XS converting into XL. So rather, let's have it as reversible step, irreversible step. So we cannot write delta H equals to delta U plus delta NGRT here, because this was only applicable in case of at least one gaseous reactant or gaseous product should be there in the reaction. So this is not applicable. Okay, and what is instead applicable would be delta H is simple delta U plus P delta V. Okay, so this is applicable. So we have to do the calculation keeping this equation in mind. This is P delta V. Okay, so next let us see some units. So 1 atm liter is 101.325 joule, and 1 bar liter would be equals to 100 joule. Okay, and 1 calorie is equals to 4.18 joule. Now let's see standard states. So first let us see for solids, liquids or gases. So standard pressure considered is, which is P naught, is considered to be 1 bar. Standard temperature in general is considered to be 298 Kelvin. Okay, now for ions, solute or solid present in a solution, for ions or solute present in solution, we can have standard concentration as C naught equals to 1 molar concentration. So example can be H plus aqueous, OH minus aqueous, K plus aqueous, Zn plus 2 aqueous, NH3 aqueous, C6H12 O6 aqueous, and etc. So consider a given reaction in which 2 moles of A gets converted into B plus 3 moles of C. So here let's say delta H is equals to X kilojoule. So delta RH or delta HR both mean the same, and that would be X kilojoule per mole. So where delta RG or delta HR is the enthalpy change in reaction, or enthalpy of reaction simply. And here specifically per mole means per moles of return reaction. Okay, so which simply means enthalpy delta RH or delta HR, which is X kilojoule per mole, is per 2 mole of A per 1 mole of B and per 3 moles of C. Okay. Next, let's see another reaction in which 4A gets converted into 2B plus 6C. So delta H for this reaction is, let's say, 2x kilojoule. So delta RH for the same reaction would be 2x kilojoule per mole. Okay. Next, let us see Kirchhoff's law. So let's see next concept, which is Kirchhoff's law. Which says that for chemical reaction or phase equilibrium, for a chemical reaction or phase equilibrium, we can say that variation in delta RH or delta RU with temperature can be written as variation in delta RH with temperature can be written as d of delta RH would be equals to delta R CPM dt. Okay, and variation in delta RU with temperature can be written as d of delta RU equals to delta R CVM dt. Okay, and at standard state, what can we write? At standard state, we can write that integral of d of delta RH naught would be equals to integration of delta R CPM naught dt, d capital T. Okay, and delta H naught would be the standard enthalpy of reaction, delta RH naught rather. Standard enthalpy of reaction. Okay, now we can write that delta R CPM would be equals to summation of RP CPM of products minus summation of RR CPM R. Okay, where RP and RR are the stoichiometric coefficient of product and reactant respectively. Stoichiometric coefficient of products and RR is stoichiometric coefficient of reactants. Okay, so with this we come to the end of this lecture. In the next lecture we'll be seeing more on Kirchhoff's law. So till then, good luck and goodbye.